Hello everybody, welcome to this episode of TurboShed, and in this episode we are going to try and build this engine for less than £1,000 into 1,000 horsepower. So this is the block that we ran the big ends in last year. Unfortunately the crank from that engine was scrap. We had it crack tested and it was cracked everywhere. So our grateful thanks to Owen Atkinson for sorting us out with the crank. Obviously the crank that we've got in this block were never together. So the first thing we're going to do is we've got everything cleaned up. We have brand new ACL race big end main bearing shells. We're going to put the shells in. Part number for the shells is here. Should be here, and we're going to plastic gauge them, and let's just check the clearances, get the main bearings and the thrust sorted out, and if they're okay we can move on and start looking at the big ends. So we put the bottom shells in, we've dropped the crank in, make sure that runs clearly, and then we tear off small strips of the plastic gauge, green in this case because that's the correct thickness for the clearance, and we lay it along the top of each of the journals. The main caps are then installed, we put the assembly lube on, and then we will tighten down and torque all of the bolts, and then we can remove them and we can check the plastic gauge thickness. The main thing is to be careful you don't rotate the crank, because otherwise it damages the plastic gauge and you get incorrect readings. Just match the strip width with the plastic gauge width, and that's your clearance. The wider the strip, the tighter the clearance is. Well, there we are, we've plastic gauged all of the main bearings. So the spec bearing 1 and 5 should be 17 to 33 microns, and 2, 3, 4 29 to 45 microns. That's the standard Toyota spec. And actually what we've got is so number 1's towards top clearance, 2 is towards bottom, 3 is nominal, 4 is towards top, and 5 is towards top. So I think we'll take that. They're all okay on the plastic gauge, so we'll just clean the plastic gauge out of the bearings there, oil everything up, grease the studs again with some assembly lube, and we can put all that in, measure the end float, and the crank's in. With the end float sorted, we can put the cross bolts in. So when they say cross bolted mains, these are the cross bolts. Well, the crank's in, end float's good, you saw us measuring that, all the clearances are good, feels really nice. So next job, I need to sort out pistons and rods. But the first job I'm going to do before I put new bearings in and do the clearances on these is sort out the compression ratio. We're going to run this up to 29-30 psi of boost, because that's how we're going to get the power out of it. And these are standard pistons and UCF 10 thick rods. So the first thing we're going to do with that is I have some Cometic 96 thou head gaskets, but they're not thick enough to get the compression ratio down to about 8.5. We could go and spend all our money and buy a set of Ross forged pistons, which are very nice and very expensive, but that's not the way we roll. So what I'm going to do is I'm actually going to assemble this up with a set of the old shells. I'm going to measure the volume with the standard pistons. I'm going to calculate the volume in the gasket, I'm going to measure the cylinder head, calculate the CR with these 96 thou gaskets, and then I'm going to work out where we are on compression ratio. And if the compression ratio is not correct, I think it might be about 9 or 9.2, that's my guess, then what we're going to do is we're going to machine the top of the pistons, because these pistons are about 8mm thick on the crown, which is crazy. And if we take half a mil off that, we should be right. So let's do some measuring, get the barrette out, put this in, see what we've got, do some calcs. So we'll put a thin smear of grease on the inside of the bore, wind the piston to the top, another smear of grease on the top of the block, use a plexiglass sheet with a hole in, and we use a barrette full of petrol to measure the volume. That's 3.8 cc. We repeat the same process on the cylinder head, measure the volume there, and then we can calculate the total cc volume and therefore the compression ratio. There we are, so we've measured the cc's, 3.8 in the cylinder here, we've got 14.6 in the gasket at 96 thou, we've got 43.5 in the cylinder head, and if we do that the compression ratio comes out about 8.9, which is a bit higher than we wanted. We were aiming for 8.5 for 30 pounds of boost, so we need to add another 4 cc, which will give us a total enclosed volume at top dead centre of just over 66 cc. So the only way we can do that, I don't want to machine the insides of the heads because the walls are quite thin. I've seen people do that on the internet, and no thank you, it just looks like a way to create hot spots to me. So the way we're going to do it is I am going to machine 0.65mm off the top of each of the pistons, because we have such a thickness on the crown there, I don't think that's going to be an issue. So we need to pop the pistons off the rods, I need to make a bit of a fixture, chuck them in the CNC lathe, and then we will have 8.5 cc without having to mess on buying expensive pistons. CNC lathe does a nice job, and obviously it's consistent when we do it here. And there we have 8 pistons, all machined, all the same deck height. So let's see what we've got. Well, this is the moment of truth. I've put one of our machined pistons in with a set of all big end shells, because I haven't done the clearances yet on those. So let's see if I have an extra 4cc, which we were aiming for. So if I've done this right, we should have about 8cc in here now. So I'll put some grease around here. More grease to seal the bore, get the plexiglass on there with our hole in, barrette is full of petrol and zeroed out, and let's see what the volume is now. There we are, we've filled that, and we now have 8.6 cc, so I think that should be spot on for our 8.5 to 1 compression ratio. Good job. Right, let's put number 2 in, and change to the new bearing shells, big end shells, and do some plastic gauging. The plastic gauge is laid in as previously. We're using the green, which is the for the smallest clearances. And again, this is just a slow process of going through and doing all 8 journals. See here, the plastic gauge has been squashed, so let's measure it up. clearances on those two bearings were 0.05 millimeters, which is within spec, and it feels really nice. There we are. So all we're going to do now is repeat that for the other three, and that's the big ends and stuff done. So yep, I'm going to get on with that, and then we'll get on with the next job, which is probably oil pump. With a thin bead of sealer, a new front crank oil seal and a new O-ring for the oil gallery, we can get the oil pump in place and get all the bolts torqued up. The aluminium casting part of the sump can go on next, so again it's a bead of sealer around it, and get all of the M6 and the M8 bolts in, run them down. Block drain plugs next, and the standard ones are all chewed up and corroded, so we made some 2-part piece with brass, taper thread into the block, and we have a taper seat for the outer part. These work really well. Cam belt drive pulley goes on next, that locates onto the keyway on the crankshaft, and then we have the pickup for the crank position sensor, and this being an early one UZ, it has a straight 12-point tape. The fixed and the sprung tensioner pulley go on next. We can run the belt round the bottom, and this allows us to put the plastic cover on, and the reason we use this plastic cover, and it's the only one we use on the engines, is that it has the timing marks on. Cam belt tensioner goes in next, and we've already reset this, and we've left the locating pin in it, because obviously we can't take that out until we have the heads on and the belt around the camshafts. Front pulley goes on, big bolt in the centre of the pulley, and we just use a block of wood to block the crank up against the crankcase so we can tighten that up. With the bottom end done, we can now install 18 of the ARP cylinder head studs. Here we are, we're ready for cylinder heads, so I have put 18 ARP studs in. The reason I haven't put a stud in this location on both sides is that if you put the ARP stud and washer and nut in that location, it will catch on your cam gears. So I always use a bolt in that location and the studs everywhere else. Other people do all sorts of odd things, like leave the washers off and cut the studs down and all sorts of bad things like that. I prefer just to use a standard bolt in that one location. If you put them together without the washers on, the clamping force onto the aluminium is too high, and the washer, and the nut will eat in because the nut diameter is too small, and it will yield the aluminium and do no good at all. So don't do that. So ARP studs, ARP nuts and washers are going on, and we are using Cometic multi-layer steel gaskets. These gaskets are 98 thou thick, which with 0.65mm off our pistons will give us 8.5 to 1 compression ratio. So there we are. So we'll put the gaskets on, put the heads on, and get everything pulled down. Our Cometic gaskets go on first. These are put on dry, no sealer or anything. They are handed, and they have to be on the right way up as well, so a little bit of care to be taken. There's the left one on, putting the right one on now. The cylinder heads, we've already cleaned the surfaces, checked them for flatness, and we can drop those on over the top of the studs. Next job is to put plenty of assembly lube on the threads, and then we can lay in the ARP washers, which are special washers, and then we can put the 18 ARP nuts plus the 2 standard Lexus bolts. Well, it's time to get brave and torque it down. So we've got 9 ARP studs and nuts with plenty of ARP assembly lube. We've got the standard bolt in this location here, so it clears the cam gear. So the standard torque for the bolt is 39 Newton meters plus 90 degrees, and for the ARPs it's 60 foot-pounds, which is 80 Newton meters in 3 stages. So we're just going to have to work our way through with these 2 torque wrenches and do it. They always feel, or they start to feel just a touch soft at 60 foot-pounds. I think the last one I did to 55 because it just, you know how it feels. So anyway, we'll get brave, we'll do this up and see how it goes. There we are, they've all torqued up, they feel nice, 60 foot-pounds for everything, except the 2 standard studs, which are 39 Newton meters plus 90 degrees, which is about 55 foot-pounds it usually works out at. So I'm glad to have that done. You can see the nice thick head gaskets in here. So that's it. Next job now is we'll get the cams in. Starting to look like an engine. Here we're checking the cam timing. You just line the dots up that are on the rear. 2 dots on the left hand cylinder head, 1 dot on the right. These early 1UZs are a non-interference engine, so as long as the inlet and exhaust cam timing is correct, you can tighten them down in any orientation and then set the timing relative to the crank afterwards. One of the issues with thick head gaskets is it moves the cylinder heads upwards, and this means that even with the cam belt tensioner right off, it's pretty tight to get the cam belt on. Next job is to remove the anti-backlash spring locking bolt, which you've got to put in before you disassemble these engines, because otherwise it disassembles itself. Final job here is to spin it over a couple of times and make sure all the timing marks still line up. And my least favourite job to finish off the camshafts is doing 32 valve clearances. One of the reasons we only used 98 thou head gaskets on this, and we machined the pistons, it might seem a lot of work when you can go and buy 140 thou gaskets from Cometic off the shelf. One of the reasons we did that is that as you put thick gaskets in here, the cylinder heads move outwards, and if you do that on a V8 too much, then all of these manifolds, the two water manifolds and the main inlet manifold, don't fit. So there's a very good reason we use the 98 thou ones, and that's that if you use the 98 thou ones, then these manifolds still sit nicely, and if you file the holes about 0.5 millimetre out on both sides, it all fits. And by doing it 0.5 millimetre, it means you don't start losing gasket face and mating faces on these. If we went a lot further, so for instance the 140 thou gaskets are 1 mil thicker on each side, that moves the heads out, which is root 2, so what's that, 1.4 millimetres, and you end up having to take these holes out quite a lot further, and these wall thicknesses where they mount are quite thin. So that's why we did what we did. But okay, I've filed the holes on these. We'll put the water bypasses in. I've just laid the inlet manifold on for now. We can't put that on properly because I need to put the knock sensors in, and currently the knock sensor mounts are still on the Lexus. And then we can turn it upside down, finish the sump, and then we can get this old girl in. So there's a couple of modifications we've done on the water circuit here. The car's always run hot, and I think there's a number of issues with that. So I thought I'm going to try one without a thermostat, and you can't just take the thermostat out of a 1UZ because it has a bypass, and if you take the thermostat out they run hotter because all the water just goes straight through the bypass and not through the radiator. So there's an easy way to fix that. On the 1UZ, this is the water inlet, goes into the pump. The water then goes out both sides into the block, down to the back of the block, up to the back of the head, and then forwards, and then comes out through this, which goes to the radiator. So that's the general water flow system, and the bypass just goes straight between these two, so it takes the radiator out of it. So if you're going to take the thermostat out, an easy way to do this, and we're going to check this, is that you weld a bung in there and you chop the back off the thermostat housing and weld that up, and then all of a sudden, if this goes on here, the water cannot go through the bypass. So the only water flow that we've got is in here, which won't have a thermostat in, and coming out here. There is the two heater bypass hoses at the back. I'm not sure whether to block those off or whether to leave them open. I haven't decided yet. The one that returns actually goes into the pump inlet, and the outlet one comes out of the rear link pipe. So I'm not sure whether that's going to help or hinder, so we're going to try that. So that's what we've done with the water system, and the other thing I've done is that I've blocked up all of the holes that work for the feed around the throttle body and such like, because we don't need any of that. So we're going to try this, and hopefully it'll help it run cooler. The engine's back upside down, so we can put on the oil pickup pipe, followed by the baffle plate. Finally we can spin the engine over so it's the right way up, and this will allow us to install our trapdoor baffle sump. The reason we do it this way up is that you can't actually put it on with the engine upside down because the trapdoors fall open. There we are, we're done. So the engine's done as far as I can, so I've got to put the knock sensors in and the injectors and bolt on the inlet manifold properly, but I can't do that because the knock sensors and the injectors are currently in the car. So that's as far as I can go with this. Next job, I need to pull the engine and gearbox out of the car, swap all the bits over that we need onto this, bolt our new rebuilt 350Z gearbox with our electron beam welded third gear and stuff, put it all together, turn it up to 11 and see if we've got 1,000 horsepower. We've got the process and method for this sorted out now, and we can get the engine and gearbox out of the car in about 2 hours. This is the rear gearbox mount coming off. The engine mounting bolts are taken out of the cross member, and then we take the cross member bolts out so we can lower it down about 1 inch, because it just makes it a lot easier to get everything out. Well, there we are. I've run out of things to take off. We've got the prop and the exhaust and everything off. Gear stick, everything's off the top. I've got the engine crane there. I'm doing this on gravel, which is insane. But there we are, and I'm doing it by myself, but that's the way we work. So I'm going to get the crane in place, hook it up, and hoik this lot out, I hope. Although we're doing this on gravel, which isn't easy, having a big, heavy-duty, long-reach engine crane does make the process easier. Oh, if only we had a 2-post lift. Well, there we are. That's not an easy job by yourself on gravel without the lift and stuff. Anyway, it's done. So split these apart, we'll get the clutch off, get the manifolds off and stuff, and the turbo, get all those bolted onto the new engine, and start putting things back together again, which is good. Gearbox is the first part that we split off. That comes off easily. We can then take off the clutch pressure plate, and we can take the discs out from our 200mm twin disc ceramic clutch, and then we can knock the flywheel bolts out. Next is our adapter plate that we take off, and that was many episodes ago when we made this, and it's still going strong. Exhaust manifolds next, so we disconnect the front flexi pipe, and then we can take off the right hand log manifold. And the heat shields in the turbo come off next. Followed by the left-hand main manifold. Well, there we are, everything's out. I've got everything stripped off this. I'm not too sure about the turbo. It might be getting a bit worn, so I'm going to send that off and get it rebuilt before we put it on, may as well. And the clutch looks decidedly dodgy. So I think trying to set it off in 4th gear and doing lots of clutch kicks and bad things like that has really hurt it. So again, I'm going to get all that measured up, and I suspect we'll be putting at least a new set of clutch plates, possibly a pressure plate onto that as well. But anyway, that's the way it is. We're just going to get it sorted out, and we'll get all the new parts together and we'll put it onto the new engine. So we transferred all the parts over onto the new engine, and here it is, ready to put it back in. The only difference is for this one, we bought ourselves an engine levelling jig, which makes the whole thing a lot easier to tip the gearbox down. Well, we're fuel tight. See if she'll start. Well, now I've connected up the engine earths, which I've forgotten to do. Hopefully it'll start. Let's give it a go. That'll do. Right, we'll put the rest of the stuff on, get some water in it and run it up to temperature. Happy days! The radiator module goes in the front, that drops in pretty easily. We can then connect up the electrics for the fan. Water hose goes on, and then we can fill it up with water. And for initial testing we always just fill the car with water rather than antifreeze to make sure everything's okay. And the final job, on goes the strut brace, and that's our engine in, done and finished. Ready to test it and get it out onto the track. There we are, we're done. Oil, water, engine in, sorted. We've got our new baffled sump on, so we'll see how that's going to work. I hope it does, because we know we've had oil surge issues. And we're going to get to the track. This is currently built up with our RX8 440cc injectors. So what we'll do is, obviously, you know, the engines, we're going to have to modify the maps to suit because it's lower compression. We'll run the engine up as far as we can go, up to 95% duty cycle on the injectors. With this, which we reckon will be 18 to 20 psi boost, that should be in the high 600s horsepower. If all that goes okay, our next video, we are flow matching some cheap Chinese injectors at 850cc, allegedly, and we will then put those in, and if they do what they say they should, we're going to be able to run our full power. which this turbo should go up to 30 psi. The Haltech will go up to just over 2 bar on the standard map sensor. And that should give us, based on everything else that we've read and done and calculated, somewhere between 950 and 1000 horsepower. So the question is, 1000 horsepower engine for £1,000. Can it be done? Well, here's the numbers. The engine was scrapped because it had run a big end, and 2 of the rods were damaged and the crank was scrap. So the engine was free. We got the crankshaft for free. Thank you very much to Owen Atkinson for that. We'll do bits of machining and stuff for him to pay him back for that. And all the rest of the parts are there. And even including 850cc injectors, that's less than £1,000. So next time you want to spend 10 grand fully forging your SR to get 300 horsepower out of it, the question is why? Bolt the 1UZ in, job done. Anyway, thank you for watching. Join us next time. We'll give an update on where we got on with this engine, and we will be flow matching injectors. Please remember to subscribe and to share the links to our videos. It all helps us, and thanks for watching.